All right, so very first thing we're going to do, kind of back up for a little bit and just kind of sort of already done this one, but we'll just make sure everybody that's good. So we're just reviewing factoring because, last test we had some factoring, had another test before that. We got one more just to try to reinforce everything that we're doing, and we're going to add in just a couple little things for this one. So we'll kind of just back up for a little bit and work on some that we've done something similar to with just a little bit of difference to it. So. Okay, so again, not doing any more x squares. Everything is x to the third or x to the fourth. We could do x to the fifth, but we're not going to go that far. We'll just do either 3 or 4. So. All right, now you're still going to kind of go back to the sheet that we had before. You've still got, if we had our factoring sheet, we've got one somewhere. Okay, so we can still do these like a trinomial, where we're doing all the ones we did before. So for this one, you would look for greatest common factor. They all have an x, so you can still take the x out. Okay, so if you take out 1x, now we've got x squared plus 6x plus 5. From there, it's just your normal factoring. We're looking for the factors of positive 5, where the sum is going to equal positive 6. There's only one way you can break down 5 is 1 times 5. So for this one, there's only one way to break this thing down. The good news is, again, if you kind of cover up that x that's out front, this one we get to use a shortcut because it's x squared, and there's just a 1 understood in front. So that one we can do x plus 1, and then x plus 5. The x that's out front is just going to stay there, so we'll just put it out front. Okay, so that one, not really anything different that we did before. Just this time, again, we got an extra x in the beginning and x to the third that we can factor out. So it's almost exactly the same thing we were doing kind of leading up to it. Okay, another one that's, again, basically the same thing. But with one little tweak to it. All right, this time, now we got 4 terms. And if we got our sheet with the 4 terms, that's where we're going to do factor by grouping. And if we do factor by grouping, we're going to group the first 2 together. We'll group the last 2 together. And the good news on this one is they're all positive, so we can still put the plus in the middle here. So if we group the first 2 together, and then the last 2 together, for this one, we can take out an x squared. Be left with x plus 2. Last one with 3x and 6, you can divide them both by 3. So it should be an x plus 2. Okay, and again, that built-in check with 4 terms is that if you do that, if this and this are the same, then we know we've done the factoring the correct way. So now we can just take the 2 numbers in front, the x squared plus the 3, put those together in one parentheses, and we'll leave that x plus 2 in the next parentheses back behind it. Okay, so a lot of what we're doing with the polynomial stuff is that we're still doing the exact same factoring we were doing before. It's just now we're starting off, instead of starting off with x squared, we're starting off with x to the third, or we'll get one here in a second, we'll do x to the fourth or something like that. So it's the exact same graphing or same factoring we've been doing. It's just we're tweaking it just a little bit because we're starting off with something a little bit more than just x squared for these. All right, so for this one, we're going to bump it up just a little bit more. So now we got x. So is everybody okay with those so far? Everybody? Okay. Again, there's nothing really big different. It's just little big differences on those. So, okay. So for this one, same kind of thing. We've got 3 terms here, so we still got a trinomial. So we're still going to use our factoring rows that we had before. So we've got 3 terms. Let's see if I can find that sheet. Okay, so we're still going to go through the setup on this one. that we've got three terms, still got a trinomial, and this one will work only for x to the fourth. So in this case, there's not a greatest common factor, so there's nothing we can do for this one. We're still going to look for the factors of negative 10, where the sum in this case would equal negative 3. Okay. If we check 1 and 10, again, we use that to kind of get the right signs on everything. B term is negative. Bigger number has to be negative. If we divide two negatives, it makes the other number a positive. Okay. So if we go 2 and 5, positive 2, negative 5. Okay, so the pair that would get us to negative 3 would be positive 2 and negative 5. All right, now some people are going, all right, so what do we, so here's the big difference on this one, is that the big difference on this one is instead of starting with x squared, we're starting with x to the fourth, and we've got x squared in the middle. So anytime they give you these, and you can do this really with any even power, is that whatever number you've got in the middle here, that's what we're going to put in parentheses. And we didn't really talk about it back here, but how this was x in the middle, we put x here and here. This one we're going to do the same thing. If we've got x to the fourth and x squared, when we factor this one, whatever this middle number is, we're just going to use that power of x. So it's going to be x squared, and we're going to have a plus 2 and a minus 5. Sorry, kind of crooked there. Okay, so if you start off with x to the fourth and a trinomial, and again, basically whatever your term is in the middle, that's what you're going to use there for both times. If this had been like x to the sixth and x to the third, you'd use an x to the third and x to the third there. It would still work the same way. So as if it's as long as it's a trinomial, as long as these numbers are even, you can still just do your normal factoring, and whatever this power is, you're just going to put this power here and here as you go through those. Okay, so trinomial, and again, that power there would go there and there. The good news is on these, you're not going to have to do any of the 8 times c and do all the stuff. This one should just be straight regular shortcut factoring, where we can find these factors of the last term and then just replace them and go here. Okay, now we're going to do the same thing on the next one, but it's going to have just a small little difference on it. Okay, so same thing on this one, where we're going to have the same setup here, but just a different kind of look at it. So we're going to do x to the fourth. Let's do minus 11x squared plus 18. Okay, still 3 terms. So we're still kind of in the trinomial thing. We still got the shortcut on this one. We're looking for the factors of a positive 18, where the sum is going to equal negative 11. Okay, we'll go through our list again. So we've got negative 11. So b term's got to be bigger. Keep the negative sign for the b term. If we do positive divided by negative, that's going to be negative. So in this case, they're both going to be negative. So if we do 2 and 9, that pair would actually get us to the 11. Okay, and again, x squared in the middle, so we'll get to use x squared for both here. We'll do a minus 2 and a minus 9. Okay, now, and this one is, that's a halfway point. So we're almost there. Anybody know, there's one more thing we can do to this one. Anybody remembering another, it's basically one more step factoring we got to do. Anybody remember the one other factoring thing we could do on one of those two things there? Let me narrow it down. Anybody remember how to factor that? Where we got x squared minus 9? For starburst, anybody? There we go. Yeah, so okay, that's the difference of two perfect squares, right? Because x squared is x times x, 9 is 3 times 3. So when you're breaking, especially these with x to the fourth, when you break them down, if you get here and you see a difference of perfect squares, that this could be, you can go x times x on that one. With the 9, you can go 3 times 3. If that's a difference of two perfect squares, then for this one, you can actually break it down twice. Now you can make this one x plus 3 and x minus 3. There we go. Okay, so again, and a lot of times on those, that's the only thing you got to be careful of, because now the one before it we didn't have to worry about it because these weren't perfect square root numbers, so we didn't have to worry about it. But this one, after we did the factoring, we got a perfect square root there that was negative. So on that one, you can take that one more step and break it down so that you're going to have that one extra step that you would go with there. Okay, now it's not going to happen every time. Okay, all right, so here we go. A couple more of these that we'll do. And kind of tying that part of it in just to make sure we're good here. All right, so for example 5, we'll go x to the fourth minus 36. All right, so again, now we're down to two terms. There's not a greatest common factor. Again, prime's not going to be an option on these. Everything in this part for the polynomials, they will factor in some way. Everybody okay that this would be 36 is 6 times 6? X to the fourth, again, you can basically cut it in half and make it x squared times x squared. So in that case, we're still looking at a difference of 2. Again, it's difference. It's two perfect square numbers. So we can do x squared plus 6 and x squared minus 6. Okay, and for that one, it's not a difference of perfect squares on this one. That's a difference, but 6 is not a perfect square. So that's as far as that one will go. All right, let's give you one more. Okay, x to the fourth minus 81. Okay, and again, still going through your same factoring rules. We've got two terms. There is not a greatest common factor, so we can't do anything with that one. So the only thing then it could be, if it's two terms, it's got to be a difference, which it is. It's got to be perfect squares. 81, again, is 9 times 9. And to get this one out to be, again, you basically just cut your power in half. So if this is x to the fourth, that would be x squared and x squared. Okay, again, difference of two perfect squares, so their answer would just be x squared minus 9, and then x squared plus 9. Okay, and again, if you're doing these, this is where, again, any answer you've got factoring-wise, that's where you got to kind of stop and think about it. That, again, this one's not a difference of perfect squares, because it's adding, but that one is a difference of two perfect square numbers. That, again, with x squared, you can make it x times x. 9, you can make it 3 times 3. So just like on the last example, you can take this one and go one more step here and make it x plus 3 and x minus 3. And this x squared plus 9 will just follow back behind it.